Okay, so in this video, we're going to go over the basic properties of logs that are useful later to solve equations. In particular, number 2 is the one we're going to be using later for solving equations. But since we're here, we'll also talk about the property 1, which is all these just come from the exponent rules that we taught in our first video of this review. So let's see, the log base b of xy, the product xy, is going to get split to like the log base b of x plus the log base b of y. This is what this says. So let's check this out, how this works. Let's see, if I start calling the log base b of x, let's call that the number n, and the log base b of y, let's call that the number m. Then this means, according to our definition of logs, that the base b raised to the power of n gives you x, and the base b raised to the power of m gives us y. Okay, so now our task, what I'm going to do is try to find an expression for the log base b of x times y. So x times y would be just using these two substitutions that I have here. Instead of x times y, I can write b to the n times b to the m. Okay, this is the same by the properties of exponents to b to the power of n plus m. Okay, now it's going to say if I wanted to find the log base b of the quantity x times y, well, that's the same as log base b of the quantity b to the power n plus m, right? So again, we're at the point where it says I want to find what is the power. I must raise the base b in order to get this quantity. Well, it's already written as a power of b, so that is n plus m, right? B to the n plus m certainly gives us b to the n plus m, if I write it this way. Okay, but now this m, this quantity n, is, let me not use the green there. This quantity n, I can write it like the log base b of x, and the m is, of course, log base b of y. So what I'm saying is that this is n, and this is m. So I got what I wanted. We proved that this certainly is true. Okay, now for our second one, do the same steps. The problem is that now I have the number n here. I cannot use in here. So let me change it and say, let me say that, because I can't use the letter n for two different things, I'm going to write here, let's pretend that the log base b of x, I have to call it a different letter because I'm using n, so let's call it a. So what that gives us is that the base b raised to the power of a gives you x. Okay, now let's see, x to the n would be nothing else than b to the a raised to the power of n. So in this situation is when you multiply the powers. And there you go. That means that the log base b of x to the n is nothing else but what power I need to raise the base to get x to the n, where the base is b. I'm going to not write this step here to get confusing with a double base, so it's just the power an, right? Let me write it backwards. I'm going to have it like n times a. Why? Because then I have n, and the quantity a was precisely over here, the log base b of x. So there we go. So we see this in practice as saying like the log base b of x to the n, that n comes in front, and it's n times the log base b of x, right? So that's the property that we're going to use a lot for solving equations. And finally, the last property we're going to see here, of course, this comes, as you can see now, from all we're using is the property, the exponent rules. So it's going to come from the third one, from the one that has the division. So now I'm going to write the same thing. I'm going to go back to x and n, it's like over here. So in fact, I'm just going to copy this. If I call log base b of x equal to n and log base b of y equals to m, now what I want to do is find the log base b of x over y. So again, I can write that this means this, that this means that the base b raised to the power of n gives you x, and the base b raised to the power of m gives you y. So now if I want to find what x over y is, like I'm finding the same steps as here, instead of x times y, I'm doing x over y. It would be b to the n divided by b to the m, and using the power rules, remember, this is b to the n minus m. So there we go. The log base b of x over y would be this power, right? The power we need to raise the base. So it's n minus m. N was the log base b of x. And m was the log base b of y. Okay, so that's how you prove these three very useful properties, that the log of the product becomes the sum of the logs, that you can bring these exponents in front of the logs, and that the log of quotient is a difference of the logs.